In the theory of equations, we are often concerned with the creation of an equation whose roots have to do something with the roots of another equation. In this presentation, and those that follow, we strive to study this situation. We start with an example, then we discuss the case of the general cubic, the case of the general biquadratic, and finally we discuss the general equation of degree n. The students are expected to not only watch the slides, but they're also expected to listen to the audio that is embedded in the file. In case the students do not get what the instructor intends to impart, the students are expected to repeat the slides and the audio as many times as is required to get a good and clear picture of what is being taught. We start with a specific example. We consider the cubic equation x cubed minus 6x squared plus 11x minus 6 equal to 0. And what we intend is we want to create another equation whose roots have to do something with the roots of this equation. And remember, we do not know the roots of this equation, and we have no intentions of finding the roots of this equation as well. We intend to find, as I already told you, another cubic equation, the roots of which are double the roots of this equation in this case. So to make the things clear, we're trying to find out another cubic equation, the roots of which are double the roots of this equation. So for example, if one of the roots of this equation is alpha, and another one is beta, and another one is gamma, then we have to find out an equation, a cubic one, the roots of which will be 2 times alpha, 2 times beta, and twice gamma, right? So how do we do that? One of the ways of doing this is actually finding out the roots of this given equation, and we can use several methods to find out that. We can use Cardan's method, but that's something which we want to avoid. Basically, without finding out the roots of the given cubic equation, we intend to find out the cubic equation, the roots of which are double the roots of this equation. That sounds daunting and difficult, but that's something which is not actually difficult, and I will demonstrate to you how this can be done. Now what we want is we want to find out now the cubic equation. Let that cubic equation be constructed in y. That's let the variable in that cubic equation be y, the unknown. So we want something like this. We want y cubed plus ay squared plus by plus c equal to 0, right? And we want y to be equal to 2x. Now putting the things in perspective, we basically have a straightforward and a very simple way of finding out this cubic equation. So this is the cubic equation x cubed minus 6x squared plus 11x minus 6 equal to 0, and we want to arrive at y cubed plus ay squared plus by plus c equal to 0, where y should be equal to 2 times x. Make sure that you have understood this three. Now look at this last equation, y equal to 2x. This means that in order to get the required equation, that's in order to transform the given cubic equation from x to y, we simply need to get rid of x and introduce y in the given cubic equation. And we can do that simply by using x equal to y by 2 in the given equation to get y by 2 cubed minus 6 times y by 2 squared plus 11 times y by 2 minus 6 equal to 0. This is the equation we got from the original equation by simply substituting x equal to y by 2, right? So what we do, we just simplify this equation in the next step to get y by 2 cubed minus 6 times y by 2 squared plus 11 times y by 2 minus 6 equal to 0, and that becomes y cubed by 8 because 2 cubed is 8 minus 6 times y squared by 4 plus 11 times y by 2 minus 6 equal to 0. Now to make this equation look better, we get rid of the denominators, and that's something which can be achieved by finding out the LCM of the denominators, and the LCM is 8, so we multiply throughout by 8 to get the required equation, y cubed minus 12y squared plus 22 times y minus 48 equals 0, and this happens to be the required cubic equation, and the roots of this equation will definitely be twice the roots of the given equation, because that's because of the substitution we used y equal to 2x or x equal to y by 2. And remember this, all of this was done without actually finding out the roots of the given equation, and that's something which you have to appreciate.